So what I want to do is talk about two different kinds of rotation. We can have something rotating like this, or we can have it rotating like that. Okay, so which way is which? I mean, if I rotate it like this, then when I look at it, it looks to me like it's going clockwise, but to you, it would look like it's going counterclockwise. And so it's like, well, which one's right? Well, they're both right, okay? But what about this? Well, someone on this side would see it going clockwise. Someone over here sees it going counterclockwise. To me, like it looks like the top of it's rotating away from me. To you, it looks like the top of it's rotating towards you. How do you describe those kinds of rotation? Well, what we do is we say that each kind of rotation, we want to define the axis of rotation and say the rotation is defined by the axis. Okay, that's how we figured out for a planet the north and south poles. Is we say, well, we figure out how it's rotating, and that gives you the poles. Well, one of them is the North Pole, one's the South Pole. How do you know? I mean, it's not like go to Mars and look for polar bears and penguins to figure out whether it's North and South Pole. Okay, Mars doesn't have much of a magnetic field, so that doesn't really tell you either. So how would you do it? What we do is we use what's called the right-hand rule. To use the right-hand rule, as it's rotating, you curl your fingers in the direction it's going. Your thumb points in the direction of the North Pole. So if it's rotating like that, we would say curl your fingers, it's this way, North Pole. If it's rotating like that, okay, then you curl your fingers in the direction it's going, and that's the North Pole. If it's rotating like this, you curl your fingers in the direction that it's going, and the North Pole is pointing down. Well, we don't just say North Pole. What we do is we define the angular velocity vector. So we would say the angular velocity vector is defined by your thumb. So if it's rotating like this, you curl your fingers around like that, and that's angular velocity up. Okay, so this is angular velocity up. This is angular velocity down. This is angular velocity that way. That, what's that? That's going to be angular velocity off in that direction, like that. Okay, so that's how you do this using the right-hand rule. The right-hand rule allows you to find the direction of the angular velocity. We're also going to realize that it also defines the angular momentum vector as well. So if it's rotating like that, then the angular velocity is that way, therefore the angular momentum is that way. Okay, the angular velocity and the angular momentum are not defined by the direction in which it's turning. They are defined by the direction of the axis of rotation. So let that sink in. It's not defined by which way it's turning. It's defined by the axis around which it's turning. So in this case, it's turning towards you and towards me. The top of it's going towards you. The bottom of it is going towards me. Okay, that's the direction of motion. But the angular velocity and the angular momentum is that way, to the side. Okay, so this is how you use the right-hand rule.